Alright, so today's lesson is going to be on surface area of right prisms and cylinders. So the surface area is the area all the way around the solid. So there's some vocabulary we need to know here. We have bases. Now, in a right rectangular prism, we actually could have three different sets of bases because bases of prisms and cylinders are congruent. So in this oblique triangular prism, we're not going to do the surface area of those, but this shows the bases are these triangles here because those are the two congruent matching sides, exactly two matching polygons, or in cylinders, circles. Now, for a rectangular prism, the top and the bottom fit that description, but also the front and the back and the left and the right. So in our class, generally we want you to use, if it's a box, we want you to use the top and the bottom. Any other shape, it's going to depend on where they are. So for example, here the base is on the top and the bottom, but here in this hexagonal right prism, the base is in the front and the back. So it just depends how the solid is arranged. Okay, the height. Now, the height of the prism, some students get confused. So some students look at this and they think the height is right here. That's not the height of a prism. The height of a prism is defined as the distance between the bases. So the height of this prism is actually the distance between these two hexagons. Okay? We have lateral faces. That's not that big of a deal. We have lateral edges. That's not that big of a deal. It's not going to be something that we really use all that much. So here they're just showing you what this is. I don't believe there'll be any other references to that. So oblique just means it's at an angle, kind of like diagonal. It's off to the side. A right prism goes straight up and down at a right angle. All the lateral edges are at a right angle to the base. Okay, so I think that's enough introduction. So you can see I've highlighted all the bases in purple, and we also have some green. So the green is the lateral area. So that means the area of the sides. A lateral in football is to the side. So lateral means side. Lateral area is the area of all the sides added together. The purple are not sides, those are bases. Okay, so the sum of lateral edges, if you think about it, before we talk about that formula, let's look at this. So if we cut this along an edge and then unfolded it out like this, we would get this, and that's called the net. Okay, so the net of the prism is when you unfold it. Now you can do this with a box in your house, but the box in your house, usually there's sides that overlap and they're glued together. So that's not a perfect net because there would be no overlapping parts. This is all lining up perfectly. Okay, so now hopefully you can see all the sides are laid out together. They make a rectangle. And so if we want to find the area of that rectangle, we would multiply the height. And then if you think about what you have down here, as we unfolded that, these sides are the perimeter of the base. So the lateral area is the perimeter of the base times the height. And that gives us the area of this big rectangle here. Now, the surface area is going to be the green part, the lateral area, plus 2 times the base area, because there's two bases. All right? So I think that pretty much explains where we're going with this. So what we would like you to do is memorize. You can see at first, on our first few tests, what we normally do in person is we give you all of these answer lines. We want you to write all of these things down here. So that's 5 things. And later on, once we've done this for a couple weeks, then we expect you to write this out yourself, kind of memorize it. So HP, LAB, Lab. HP is like a computer printer company, HP here at Packard. And Lab, Lab, and then surface area. So I don't know if that helps much, but so we have a right rectangular prism with a height of 2 feet, a length of 5 feet, and a width of 4 feet. So we could sketch that out. I'm not going to be able to do that very nicely here, but so I could have used a ruler. It would have looked a little bit better here, but I guess that'll do. So it says the height is 2 feet, the length is 5 feet, and the width is 4 feet. So the main thing here is usually when we test this, we give you a picture, so it won't be a big deal. But so we want to go by the height. It says the height is 2 feet, so we're going to put 2 feet right here. Now the perimeter of the base is a rectangle. If you want to emphasize that even more, you could draw it from the top looking down. And so we can say that these are both 5 and these are both 4. So the way I like to think of the perimeter is, especially of a rectangle, is I'm going to get the two sides that are different added together, and then I'm going to multiply that by 2. Now you also could multiply each side by 2 and then add this together, but that's 3 calculations, and I would rather just do 2 calculations. So I want to add and then multiply. So that's 9 times 2, that's 18. So, and perimeter is also measured in feet. So now we have those two things. Alright, now the lateral area is what we get when we multiply these two things together. So it's going to be 18 times 2, which is going to be 36 feet squared. Alright? And we just give 1 point for each line here, and then we give a point for the units on the written test. So the base. Now we said if it's a box, we want you to use the top and the bottom as the bases. So this is the base here. This is the base up here. There's also a base on the bottom. Remember, technically we could say the base could be the front and the back, or the left and the right, because a rectangular prism is special. Okay, so now we need the area of the base. So this is just a rectangle, so it's just length times width, so 4 times 5 is 20. So that's going to be 20 feet squared. So you want to make sure that you get your units on there. Now the surface area is going to be the lateral area. Suppose I could keep the green for that. 36, and I could put the units on there if I wanted to, but I guess I could have done this over on the side and just put the answer there. Maybe that would look better. So we've got the lateral area, which is 36, plus 2 bases, and the base was 20. Except I was using purple, but I don't know if that's going to show up. Alright, doesn't matter. Okay, so 2 times 20 is 40, so the bases are 40, and that's 36. So that's going to be 76 feet squared. And so that's primarily what we're doing. So we just want you to memorize that process. If you just do this over and over again, it should be a pretty easy lesson. So now we're just going to do it 2 more times. Same thing. So now would be a great time to cover this up and pause the notes. And everything, the rest of this lesson, the cylinders are a tiny bit different, but it is following the same pattern. Okay, so hopefully you paused it and tried this yourself. I'm about to do it. So the height, remember we said when you have rectangular prism, we're going to use the top and the bottom as the bases. So the height is going to be 9 centimeters. Now the perimeter of the base, we've got 2 times 4 plus 16. So that's going to be 20 times 2 is 40 centimeters. Okay, and to find the lateral area, we multiply these two numbers together. That's why we're having you write them down this way, so it just follows this nice, easy pattern. So 9 times 40 is 360 centimeters squared. Okay. Now down here, the area of the base is 16 times 4, which maybe some of you realize that is 4 cubed, which is 64 centimeters squared. We can get those units down there. Sometimes I encourage students to put those units on there before we start. It's the same thing over here. The height is going to be in inches. The perimeter is going to be in inches. The lateral area is going to be in inches squared. The base area is going to be in inches squared. And the surface area is going to be in inches squared. So just want to be careful there. Alright, so down here, remember we have 2 bases, so 2 times 64. So 2 times 64 is 128. I'm just going to write that over here. And then 8 So 488 centimeters squared. Okay, now if it's too fast, pause the video, think about it, rewind it, and then come try this problem. So the height, it's not talking about the height of the triangle, it's talking about the height of the prism. So the height of the prism is the distance between the bases. The bases are the two congruent polygons. So the height is going to be 10 inches. The perimeter, that's telling us it's an equilateral triangle. They're all 6, so 6 times 3 is 18 inches. And if we multiply those together, it's going to be 180 inches squared. Now the triangle is going to be, the base is going to be a little bit trickier. So I'm going to draw that looking straight down, and it's an equilateral triangle. So that means that this is 60. They're all 60, 60, and these are both 30. So if we're going to find the area of that, the easiest way probably would be 1/2 base times height. So the base is 6. So we have 1/2 of 6 times the height of that triangle. Well, this is going to be half of the side, so that'll be 3. That's the short leg. This is the long leg of a 30, 60, 90 triangle. So to get from the short leg to the long leg, we multiply by radical 3. So that's 3 root 3. So the height is 3 root 3. So 1/2 of 6 is 3. That's going to be 9 root 3 inches squared for the area of the base. And then our final answer, I might not have given myself enough room there, so that's why one of the reasons why we suggest using pencil a lot. So this is going to be 180 plus 2 bases. We have 2 of those. So if we multiply it by 2, instead of 9 radical 3's, we're going to have 18 radical 3's. And that's going to be inches squared. Okay? The same thing over and over again, this entire lesson. Now, cylinders, one tiny difference, but basically it's the same thing. So you can see on the cylinders here, if we take the net of a cylinder, remember the net is when we unroll it, cut it along the edges, and then unfold it. You could do this with a soup can or a vegetable can or something like that, but be careful because the edges would be sharp if you cut it open like that. You can do it with a label, except the label is glued and it usually rips when you take it off. But maybe you've done that with a water bottle, taken the plastic label off, and then if you cut it and roll that out, you'll see it makes a nice rectangle. So even though we have a cylinder which is rounded and curved edges, when we take a label off and we cut it straight down and we roll it out, it makes a rectangle. So you can check that if you're having doubts about that. Now, some teachers and some places, even our textbook, they write this like it's a different formula. So they have the lateral area. Okay, the lateral area is the circumference times the height, just like the lateral area. Because if you think about it, if we unroll this, what is this length right here? That's the circumference. So that's the circumference of this circle along here, and this is the height. So it's the circumference times the height. Now it's the same pattern. We just put a C here instead of a P, but the steps are the same. Now I see textbooks and they list it out like this, and to me that makes it like then you think, oh, it's another formula and it's confusing. It's not a different formula. It's just that the perimeter of a circle is called the circumference, and the formula for circumference is 2 pi r. Circumference is 2 pi r. So I don't like writing the formula like that. I just like writing it like this because then it's basically the same formula as prisms. So let's take a look and try it out. Oh, and then the surface area is going to be the lateral area, same, plus the 2 bases. Now again, some books and teachers, they write it out like this, and you see, oh, the 2 pi r and another 2 pi r, maybe you can factor a 2 pi. Like, why? You're just making it more complicated. Just make it the same as a prism. So if you look at this now, and you see these things over here, you go, oh, that's the same as what we just did 3 times. This is the 4th time, and the 5th time, and the 6th time down here. So it's just the same thing. So here, the height is 8 meters. The circumference is 2 pi r, and r is 4. So that's going to be 8 pi meters. Okay. Now we're going to multiply those together. Same process as the front page of the notes. So that's going to be 64 pi meters squared. Okay. Now here we have a circle, and the area of the base, the area of that circle, is going to be pi r squared. So that's going to be 16 pi meters squared. Okay. Now, the surface area is 64 pi plus 2 times 16 pi, because there's two bases. So 2 times 16 is 32. So we have 64 pi's plus 32 pi's. That's going to be 96 pi's. It's a lot of pi. Okay? All right. 3 to go. 3 to go. Now, this time, they're asking us to find the height. Okay? So they're asking us to find the height. So I'm going to use height for height. Now they're talking about a cylinder here, so then I'm going to want the circumference. So the circumference is 2 pi r, and there's r. So 2 pi r. So 2 times 9.5 is 18 plus 1, so it's 19. So that's 19 pi. We could put the units on there if you, that's going to be inches, that's going to be inches. So the lateral area, now we still need to go down to surface area, if you notice here, because they gave us the surface area. So we need to still have all this stuff. So this is going to be 19 pi times h, because that's how we get the lateral area. We multiply those two things together. Now, base area. So the base area is going to be pi r squared. So that's 9.5. I wonder... I was thinking about switching to a fraction, but it's not really easier. So 9.5 pi r squared. 9.5 squared. So if we take 9.5 times 9.5, that's going to be 47, 0, then that's going to be 45. Carry the 4. 81 and 4 is 85. So that's 5, 12, carry the 1, that's 10, carry the 1, that's 90. There were 2 decimals up there, so 2 decimals down here. So 90.25 pi inches squared. Okay, now, they told us that the surface area was 925.2. And the surface area is the lateral area, which is 19 pi times h, plus 2 times the base area. So 2 times this would be 180.5 pi. Okay? Now, we're solving for h. So if we're solving for h, we want to get h by itself. So we're going to subtract this from both sides and then divide by 19 pi. So h equals 925.2 minus 180.5 times pi over, so we would subtract this over here first, and then we would divide both sides by 19 pi. Now on a calculator you want to be careful. You probably would do, it depends on your phone, it gets a little tricky, because when you want to do this minus this times this, so you got to multiply these. So it just gets a little tricky how you're entering that. You might want to put a parenthesis. The calculators are nicer, especially the graphing ones, because you can list everything on there and take a look at them. Okay. So if you do all that out, that is going to be approximately 6 inches. So you might want to try that on your calculator and see if you can get it to be 6.00. I think it's 000. Okay. Alright, so let's look at another one here. So find the surface area of a 3 radical 3 foot right prism. So you need to think about what that means, and what it means is that's the height of it. If they're telling you that you have a 4-foot prism or a 4-foot cylinder, generally that would be the height of it that you would associate that with. Now again, you're not really going to have this issue in class because there'll be a picture of it pretty much, I think, all the time. So that is 3 root 3 feet. Okay, now the base is a hexagon. This is not a good looking hexagon, but it'll have to do. Alright, so there's our hexagon, and we're supposed to know in a hexagon we're going to have a 30, 60, 90 triangle, and it says the apothem is 6 feet. Okay, so we're also going to need the sides so we can find the perimeter. So this is the long leg, and we're going to the short leg. So that's actually dividing by root 3. And we're going to need to rationalize that. So that's going to be 6 over root 3, root 3, root 3. So that's going to be 6 root 3 over 3, which is 2 root 3. So the short leg is 2 root 3. Okay? That means that the side of the hexagon is 4 root 3, because this piece is 2 root 3. So all the way across would be 4 root 3. So the area, perimeter, sorry. So now we need to do the perimeter of that. So we just found one side. So there's 6 of those, so if we multiply that by 6, 4 root 3 times 6, that's 24 root 3 feet. Okay? Now, if we multiply these two together, if we multiply this times this, that's how we get the lateral area. We multiply these two together. That's why we have you set it up this way. You always multiply those two things to get this. So root 3 times root 3 is 3. 3 times 3 is 9. So I'm going to have 24 times 9. Okay? Be a good idea to pause and do some of this stuff yourself. So 216 feet squared is the lateral area. Then the base. So the base, the area of the base is a regular hexagon. So it's 1/2 AP. Well, we have P right here. So that's 24 root 3. So you can do this a couple different ways. Maybe half of 24 is 12. 6 times 12 is 60 plus 12 is 72 radical 3. So the base is 72, one of the bases is 72 radical 3 feet squared, and we have 2 of those. So we're almost done here. So that's going to be 216 plus, we have 2 bases, so we have 144 root 3 feet squared. Okay. Now we get to our, so that's probably an honors question there, and this is an honors question. So let's check this out. How do I want to focus on this? So it says the surface area of a right cylinder. Okay. So we have this cylinder, and the radius is 6 centimeters, and a height of 9 centimeters. So that is going to be right here. That's going to be 9 centimeters. And then we have the other base. You're supposed to draw a dotted line if we can't see it, because that would be behind there. But okay. And then there is a hole. It has a 2 centimeter hole in the center. So that is going to put us here. Now, if the hole is 2 centimeters, that's talking about the diameter of the hole. You're saying how big the hole is. It's a 2 centimeter hole. You're talking about the diameter. So the radius of that circle, the hole, would be 1 centimeter. Okay. Now that's going to go down through. So it kind of looks like maybe a paper towel roll, if you're trying to visualize what this looks like. Okay, or some sort of bead or something, but a paper towel roll probably is the easiest thing to, except it's much smaller because it's only 6 centimeters and 9 centimeters. But okay, so we want to find the surface area of that. So the first thing we can do is we could just find the surface area, pretend there's no hole. Okay, so let's just do the cylinder as if there was no hole in it, like that. Okay, so the height's 9 centimeters. Circumference is 2 pi r. R was 6, so that's going to be 12 pi centimeters. Okay, so we multiply that, that's 90 plus 18, so that's 108 pi centimeters squared. Okay, now the base is pi r squared, so that's going to be pi times 6 squared, so that's going to be 36 pi centimeters squared. And the surface area is what we would get if we need to have two bases, remember? So we have 108, and then 2 times that is 72, so that's 180. So the surface area is 180 pi centimeters squared. Okay. Now, let's think about what we have here. So I was talking about the hole there. I did that in red. So we have a 2 centimeter hole. That means the diameter is 2 centimeters. That means the radius is 1 centimeter. Now, if you think about it, if we have a hole that's a circle missing here, then that is part of the surface area of the base that's missing. Okay? So if we find the area of that, that's going to be pi r squared. So that's kind of interesting, but it's pi, and that's centimeters squared. So that's the area of this little circle right here that's missing. That's the hole where the tube is, where the cardboard tube is through the toilet paper or paper towels, whatever. But we also have one of those down here that's missing as well. So we're missing 2 pi centimeters. So we need to subtract 2 pi centimeters. Those are the two holes, the hole on the top and the hole on the bottom. Now, the last part, if you think about it, let's pretend this is a piece of metal and it's a part of a machine that needs to be underwater. And so, since it's underwater, we need to make sure that it's coated with a rust-proof coating. And so, we want to coat the outside, but we also want to coat the inside of that tube. When you look at a paper towel roll and you look inside there, you can see the cardboard. It's exposed to the air. So if that was underwater, that would all be, water would be touching the cardboard tube in the middle. And so that is part of the surface. We tend to think of the surface as the outside, but the surface of an object is anything that's exposed to the air. And so that tube, when you look at a paper towel, is exposed to the inside. Okay, so here's what I'm talking about. We can see the surface, so obviously all the toilet paper on the outside, that's the surface, right? But if we look inside, this is part of the surface also. That counts as the surface of this object. Now, if it was closed off, then we wouldn't count that. Okay? But it's not. We can see inside there. So that's what we're talking about. It's the first time I ever used that. I guess I have a roll of paper towels in my classroom, and I probably have used that before as well. Okay, so let's finish this up. We're almost done. So what we need is, if you think about it, we need the lateral area of the tube, the cardboard tube, because we don't have the bases. That's a hole. We just need that cardboard that's exposed in the middle. So if you think about that, that's going to be the height and the circumference and the lateral area of that cardboard tube. So the height is the same, 9 centimeters. The circumference is 2 pi r, and r was 1, so that's just 2 pi. And then if we multiply those together, we get 18 pi centimeters squared. So that is the lateral area of the tube in there. And if you don't understand that, come to office hours and I can try to talk about it a little bit more. So that's going to add to the surface area. This is going to subtract from the surface area. So if I take 18 pi minus 2 pi, that's 16 pi. And if I add it to that, it's going to be 196 pi centimeters squared. And if you thought that was hard, it was. It's an honors geometry question. So it's about that time. Have a good day.